Thank you. Thank you. Thank you very much. Imagine a material that is beautifully engineered, that to produce it will consume minimal energy, that actually sinks carbon dioxide. And it simply grows. We don't have to manufacture it. And we can harvest it in 3 to 5 years. And in the process, it will employ millions of people in rural communities in the developing world. And it's very cheap. There is a material. It's bamboo. Bamboo has thousands of applications, which range from paper, kitchen utensils, floorboards, clothing, and even allegedly, the bristles in this toothbrush contain bamboo-derived charcoal. However, speaking as a structural engineer, what fascinates me about bamboo is just in its natural shape. As I said, it's beautifully engineered. Take its shape. The fact it's hollow instead of solid makes it 4 times more efficient. Its nodes, concealed diaphragms, they stiffen the walls of the element so it buckles less. It's less likely to buckle. And they're closer together where they're most needed. Its fibers are 3 times stronger than structural steel. And they're very cleverly distributed. For example, in the wall, they're concentrated towards a perimeter, making the section 10% more efficient than if they were just randomly distributed. You might be asking, well, yeah, that sounds interesting, but how does that compare against man-made materials? So let's do like a thought experiment. How much would this piece of bamboo take? What would be the maximum safe working load of a 3-meter beam made out of bamboo? And that would be roughly around 290 kilograms. So now, how would that compare to, say, steel? Well, if we limited ourselves to commercial sizes of steel, a steel section that would achieve the same safe working load would be about that size, which is smaller, you'll say. So it's not a very fair comparison you're going to do, David. Let's do something a bit more comparable. So I've dreamt up a size that you can't buy. You'd have to have specially made, but there's no reason why we can't assume it, which would be this size, 84 mil diameter. So how do they compare? How do these materials compare? So in terms of mass, the hypothetical steel section would weigh around 7 kilograms. The commercial one, the one that we really can buy, would weigh around 10 kilograms. Whereas the bamboo one would weigh just short of 6 kilograms. So in terms of strength to weight ratio, bamboo is as good, or if not better, than steel, which is pretty impressive. However, what really matters is cost. And the currency I'm going to tell you about is carbon dioxide. So, the carbon emissions associated with making these sections would be around 10 kilograms for the hypothetical steel section, around 15 kilograms for the commercial size section, and if this bamboo is used within 500 kilometers of where it was sourced, it would be just 1 kilogram. So that's really a substantial difference in terms of efficiency. However, there's more. this piece of bamboo stores within it around 10 kilograms of carbon dioxide, or the equivalent of. That means, considering the 1 kilogram we use to process it, that we're storing, or we're capturing from the atmosphere, 9 kilograms of carbon dioxide. Which means that if I choose to make this a beam out of bamboo instead of steel, we would be making a saving of around 19 kilograms of carbon dioxide. That equates to the emissions produced by an average European car over 150 kilometers. Now, this carbon storage only remains there for as long as that piece of bamboo is in a permanent structure. But say if 50 years down the line we demolish this structure and then we burn the bamboo, we go back to this situation because the 10 kilograms will return to the atmosphere. It's still better than steel, but not as good as this. So, however, if we burnt it and generated electricity, for example, and in the process avoided burning a fossil fuel, which would introduce new carbon dioxide to the atmosphere, it would be sort of the equivalent of making this storage permanent. Now, if there was someone from the timber industry here, they would say, hang on, that's true also for timber, and it is. However, bamboo has one key difference with respect to timber, is that it takes 3 to 5 years to be harvested. It only takes 6 months from the moment it emerges to reach its full height, up to 20 or 25 meters. So, in the war against carbon emissions, bamboo is a weapon that we can deploy sooner. And bamboo has other environmental qualities. For example, its forests have a complex root network that control erosion and regulate the water cycle. And by the way we harvest it, in which we only extract some of the mature culms, in the forest, wildlife can find sanctuary. One of the great challenges of the 21st century will be the urbanization of the developing world. It's estimated that 2 billion people are going to be moving to the cities over the next 30 years. And in the process, huge carbon emissions will be made associated with building the houses, the schools, the roads, and the infrastructure that this will require. Many of these countries are in the tropics, and they can and they do grow bamboo. In fact, it's estimated that 1 billion people live in bamboo housing across the world. Not this sort of bamboo housing, nor this sort of bamboo housing, which in fact is an office building. More like this. And it's very likely at some stage in their life they will aspire to upgrading. And very likely they'll upgrade to something like this, a concrete, masonry and steel house. However, if we could persuade 100 million families around the world to move into a bamboo house like this one, and if each one of these houses consumed the equivalent of 4 tons, which is quite modest, of bamboo and bamboo-related products, we would sequester from the atmosphere the equivalent to 500 million tons of carbon dioxide. And it's likely we would also avoid the emission of another 500 million tons from making all the concrete and steel and bricks that would normally be used. 500 million tons of carbon dioxide is approximately the total greenhouse gas emissions of the UK in 1 year. However, to achieve this, things have to change. We have to make bamboo mainstream. But unfortunately, there isn't enough research into bamboo, which affects the development of codes and standards, which results in that architects and engineers do not design enough with bamboo. They don't specify it, which affects then demand. And because there's perceived to be no demand, researchers are not interested in bamboo. So we somehow have to break this vicious circle. We have to start researching it a lot more so that we can develop the codes and standards that will then empower the architects and engineers to specify and design with it. Thus, making demand much larger. So, we have to research it. Academics of the world, set aside those dreary grey materials that we've been researching for 100 years. Sign up to this worthy cause. Promote it. Governments of the world, abandon those pipe dreams. This is a real carbon capture and storage system which you can transform into houses. Specify it. Clients, architects, if you're going to build something in the tropics, demand that the structure is made out of bamboo. Design with it. Structural engineers, in the context of the 21st century, bamboo is the new steel. Teach it. Lecturers. Empower young generations of architects and engineers to be able to break this vicious circle. Grow it. Invest in bamboo. And let this wonder of nature flourish and prosper. Thank you.